Welcome to our next lesson. We're finding equations of lines using this handy dandy formula right here. So this is the slope-intercept form of a linear equation, y equals mx plus b. Let's get started. Okay, so we're on page 147 in your book, and there was this fun activity we were going to do in class. Where you were going to stand up and help me out, and I was going to punch a hole in a water bottle. And then you were going to put your thumb over the hole, and then maybe one of your classmates would get a timer, and another classmate would have a ruler, and then we'd have a bucket on the floor, and we'd let the water run out of the water bottle. So before we let any water out, we're going to measure the height of the water in the water bottle, and let's say it was 15 centimeters of water in there. Okay, now you take your thumb off, water starts running into the bucket, and after 5 seconds, someone says, stop! You put your thumb back over it, and now when we measure, there's only 13.5 centimeters in the bottle. And we do it again, and now there's only 12 centimeters, and again, and there's 10.5 centimeters, and then 9, and then 7.5, and then 6, and then 4.5, and then 3. Okay, so we've recorded our data, we throw the water bottle away, and now we're going to use that data to make a point. So please graph the data on the grid below. Okay, so before we can graph, we need to know what's x and what's y. So x is the time in seconds. If you have time, that's usually your x. That's the input, right? This is the thing that was already drawn in the chart. So time's going to go by. Y is the output, because that's the thing that's changing depending on how much time goes by. So here's my x-axis, and here's my y-axis. Always label your axes. So when x is 0, this is 0 for x, y is 15. So I'm going to put a point right here. When x is 5, y is 13.5, which is a little tricky. But I know 13 is halfway between 12 and 14, so 13 and a half is like 3/4 of the way up. And then at 10, the output is 12. After 15 seconds, we have 10.5 centimeters of water. After 20 seconds, we have 9. After 25 seconds, we have 7.5. After 30 seconds, we have 6. And then 4.5. And finally 3. All right. Hopefully your graph looks like mine. The question is, does the relationship between time and height of water appear to be linear? Explain your reasoning. All right, well, I hope you said yes, it does appear to be linear. But explaining your reasoning, we have to know what are the characteristics of a linear relationship. So when we find a pattern between an input and an output, we call that a relationship. And there are a lot of relationships out there in math. Relationship. So a linear relationship is characterized we can characterize it in 2 ways. Please don't say that there's a pattern, because there are lots of patterns. And if the dots all lined up in a pattern that looked like a U, that would be a pattern, but it would not be linear, right? So just because there's a pattern doesn't mean it's linear. There are 2 ways to define a linear relationship. The first one is the graph of the data forms a straight line. Yeah, so if you have a graph, straight line, I don't know why I have an S there, forms a straight line. If you have a graph, it's easy to see if it's linear. You could put your straight edge right on top of all your points and draw a nice, crisp, straight line through them, right? But what if you don't have a graph and you don't have any graph paper? Then there's another way to tell if you have a linear relationship, and that is A linear relationship will always have a constant rate of change. Or another way of saying that is a constant slope. So no matter which 2 points you pick from this big table of points, the slope would be the same. So you can see the linear relationship in the dots here in the graph. So let's move on and look at the linear relationship in the table. So find the slope of the line. So we're going to pick 2 points off this line. I'm going to pick this as one of my points. So the input for this is 0, and the output is halfway between 14 and 16, which is 15. So that's 1 point. And then I'm going to use the last point on this chart. So the input is 40, and the output is halfway between 2 and 4, so that was 3. Okay, now if I want to find the slope of the line between these 2 points, I'm going to set up my xy table. I got 0 for x and 15 for y. I've got 40 for x and 3 for y. So when time is 0, we have 15 centimeters of water in the water bottle. When time is 40 seconds, we have 3 centimeters of water. To find the change in y, remember the slope is the change in y over the change in x. Change in y, I'm going from 15 to 3. So hopefully everybody can see that's a decrease, right? So that's going to be a negative change because I have less water in the water bottle. That's what happens when you punch a hole in it. So that's a decrease of 12. And then the change in x, I go from 0 to 40. That's an increase of 40 seconds. So the change in y over the change in x is negative 12 over 40. And of course, we can simplify that. 2 times 2 times 3 for 12. 2 times 2 times 2 times 5 for 40. Cancel some 2's, and I get 3/10. Remember, it was a negative fraction before you started simplifying it, so it's going to be a negative fraction at the end. So the slope is negative 3/10. That doesn't mean it's a constant slope, though. To check if it's a constant slope, I'd find the slope between 2 other points. Let's use a different color. Come on. Oh, color? Pen color. There we go. Here we go. Let's use red. So I've got 2 different points. This is a nice one. So this is an input of 10 and an output of 12. When x is 10, y is 12. And this is also a nice point. So the input is 30 and the output is 6. I can use any 2 points I want. Use points that are easy, right? I'm not going to use 7.5. Why? When I've got easier points here. So I'm going to put these in a table. And I got 10, 12, and I got 30, 6. So from 12 to 6, that is a decrease of 6. From 10 to 30, that is an increase of 20. So the change in y over the change in x is going to be negative 6 over 20, which simplifies to negative 3/10. So it's this constant slope. The fact that the slope is the same, no matter which 2 points I pick, that's what makes it linear. So that's another way you can explain a linear relationship is you have a constant slope. So we got our slope twice. Determine the y-intercept of the line. So I'm just going to look at the y-axis right here. And I'm going to see that my graph crosses the y-axis right here at 15. So the y-intercept is going to be equal to 0, 15. Okay, describe the meaning of the slope. So remember that slope equals rate. Go back to black. Slope is equal to rate. So if I ask you for the meaning of the slope, I would like you to tell me that the water is flowing out of the bottle at a rate of -3 tenths. And then you got to have units. If you're going to tell me the meaning of the slope, put some units on that slope. It's always going to be the units of y over the units of x, because that's how you found slope, right? Change in y over change in x. So units of y are centimeters of water over the units of x, which is seconds, time in seconds. So the rate of the water flowing out of the water bottle is -3 tenths centimeters per second. Or I could say for every 10 seconds, I'm losing 3 centimeters of water, right? Describe the meaning of the y-intercept of the line. Well, the y-intercept is 0, 15. So the y-intercept is the output, the y, the height of the water, when the input is 0. And the input was time. So it's what we started with. The y-intercept is the starting value. So the starting value is going to be the y-intercept. So I would say we started with, if I write quickly, it boggles out on me. We started with 15 centimeters of water. I would say in the water bottle, but this pen stinks, so I'm not going to. 15 centimeters of water. That's what the y-intercept means. What you started with, the starting value. The output when the input was 0. Okay. Write an equation that gives the height of the water h given the time t. And this is where we're going to break out our new best friend, y equals mx plus b. Y equals mx plus b is the slope-intercept form. Slope-intercept form of a linear equation. It'll work for any, it'll work for any linear relationship. If you have a linear relationship and I ask you to find the equation, you can break out y equals mx plus b every single time. That's your starting point. It's like a frame that you're going to build your equation on. I don't see why we need to change the variables here, so I'm not going to use h. I'm going to use y. The height of the water is y. We graphed it on the y-axis. It's our output. The time, I'm not going to use t. I'm going to use x. Because the amount of seconds we graphed on the x-axis, I'm going to call that x. So if I want an equation for a linear situation, I'm going to use the formula y equals mx plus b. Now in this equation, m is going to be the same as the slope. So once you find the slope, you know what m is. B is going to be the same as the y-intercept. And x and y we keep as variables. So once you find the equation of the line, you're going to have an x, you're going to have a y. But instead of m, you're going to have the slope, and instead of b, you're going to have the y-intercept. So it works like this. Y equals the slope, which was -3/10, times x, plus the y-intercept, which was 15. Boom! There's your equation. Look how fast, how easy. If you can find the slope and you can find the y-intercept, then you can tell me the equation of any story or graph or table. Okay? So it asked, how does the coefficient of, we're not using t, we're using x, in your equation relate to the experiment? All right, so coefficient is a variable that is the number that's being multiplied by a variable. So coefficient is the number being multiplied by a variable. I sure hope that you can all see how many terms I have in this equation on the right-hand side. Ooh, yellow. Does everybody see 2 terms on the right-hand side here? -3/10 times x is a term and 15 is a term. So When they ask about the coefficient of x, they're asking about the number that's being multiplied times x. And that is the slope, right? M is the slope. So negative 3 over 10 is the slope. So the coefficient of x will always be the slope. The slope will always be multiplied times x. A really common mistake is to write negative 3 over 10 plus 15 and forget the x. That makes the whole thing wrong. So it's really important that the slope is being multiplied times x. The slope should be a coefficient, a number that is being multiplied by a variable. Now they're talking about the constant term. How does the constant term in the equation relate to the experiment? By constant term, they mean the b, or the 15 here. Do you guys see how this is a separate term? And they call it a constant term because no matter what x is, this will be 15, right? This term will change depending on x. If x is 10, this term is negative 3. But if x is 20, this term is negative 6. While if x is 10, this term is still 15. If x is 20, this term is still 15, right? The term doesn't change based on x. So we call that a constant term. Not changing is constant. And how does the constant term relate to the experiment? It is the y-intercept. Okay. So from now on, if you know the y-intercept and you know the slope, you can tell me the equation of the line using this formula, y equals mx plus b. Okay, let's do it. All I'm going to give you is a table. I'm not going to be happy with the slope. Oh no. I want the equation of the line that passes through these points. And you can do that now. We're going to break out our good friend. They told us that these points are all in a line, which means I can use y equals mx plus b. As long as it's linear, I can use y equals mx plus b. What I need to know is m, and I need to know b. So let's start with m. I'm looking for the slope. For the slope, I only need 2 points, so I'm not going to use that one, because why use decimals if I don't have to? So from 11 to 4, that's a decrease of 7, right? And from 0 to 4, that's an increase of 4. So my slope, I'm not going to write the word slope anymore. I'm just going to use the letter m. Every time I use the letter m as a variable, I mean the slope. It's going to save us some time. So the slope is negative 7 over 4. The y-intercept, I'm not going to write y-intercept anymore. I'm going to use the letter b. Every time I mean the y-intercept, I'm going to use the letter b instead. The y-intercept is the value of y when x is 0. And since x is 0 right here, I know the y-intercept is 11. All right, so y is equal to m, which is negative 7 over 4. M is always multiplied times x. So I'm going to multiply negative 7 over 4 times x. And then I'm going to add my constant term of 11. And there is the equation of the line that goes through these 3 points on the coordinate plane. No graph necessary! Are you getting excited? I hope you're getting excited. We'll do one more. Ben's Bells, a community service organization, began hanging ceramic wind chimes randomly in trees, on bike paths, and in parks around the country in 2003. A written message on each bell asked the finder to simply take one home and pass along the kindness. 1,000 bells were hung in 2003, and the number of bells increased by 2,000 each year after 2003. So we're going to complete the table, but I also am going to find the equation that represents y, the total number of bells, in terms of x, the years after 2003, right? So here's my x, and here's the y. Just like when we were doing word problems, I want you to define your variables. When you got a word problem and you're writing an equation, please define what x and y are representing. Okay. So in year 0 on 2003, they hung 1,000 bells in trees. And then they were like, oh my God, this is so awesome. People love our ceramic wind chime bells. Um, that they did 2,000 the next year. So the year after 2003, 2004, so 1 year later, the increase is 2,000 bells, right? So that takes us up to 3,000 total bells. And then the next year, another 2,000 bells. And that takes us up to 5,000. And then the next year, another 2,000 bells, which take us up to 7,000. Do you see this constant rate at work here? Every time we increase 1 year, change in x is 1, the change in y is 2,000. So we have a constant rate of change of 2,000 over 1. And if that is the change in y over the change in x, and it is, then that is the slope. So we just found the slope right now. There. Okay, the other thing that we need to build our equation is we need b. We need m and we need b. So b is the y-intercept. The y-intercept is going to be the value of y when x is 0. Well, here, in their 0th year, their starting condition, they hung 1,000 bells in trees. Right? So I'm going to break out my formula. Y equals mx plus b. Oh, I hope you're going to memorize this. Memorize this. This is really important. It's like one of the, ask your parents, do you know what y equals mx plus b is? Hopefully they'll at least say, wow, that sounds vaguely familiar. So the slope is m. So there will be no m in your final equation because we are placing m with the slope of 2,000. The slope is always multiplied times x. And then we're going to add, in place of b, we're going to put the y-intercept, which is 1,000. And look at that. We just constructed the equation that represents this story right here. All right, I hope this was helpful. We will see you in class tomorrow.